Hey, hi everyone, welcome back to this video series on Windows Server 2012, an easier way to apply subnetting. Now that you have the basics of how to subnet down, you'll learn an easier way. If you have learned a different way and it works for you, stick with it. It does not matter how you get to the finish line, just as long as you get there. But if you're new to subnetting, figure 8.11 will make it easier for you. This chart may look intimidating, but it's really simple to use once you have done it a few times. Watch the Y column on the lower end of the chart. This represents the number of addresses available to you after the two reserved addresses have been removed. Applying subnetting the traditional way, sometimes subnetting can be confusing. After all, it can be quite difficult to remember all of those numbers. You can step back a minute and take a look at the primary classes of networks and how to subnet each one. Let's start with Class C because it uses only 8 bits for the node address, so it's the easiest to calculate. In the following section, I will explain how to subnet the various types of networks. Subnetting Class C. If you recall, a Class C network uses the first 3 bytes, 24 bits to define the network address. This leaves you 1 byte, 8 bits with which to address hosts. So if you want to create subnets, your options are limited because of the small number of bits available. If you break down your subnets into chunks smaller than the default Class C, then figuring out the subnet mask, network number, broadcast address, and router address can be confusing. To build a sturdy base for subnetting, study the following techniques for determining these special values for each subnet, but also learn to use the more efficient technique presented in the later section. Quickly identifying subnet characteristics using CIDR, which means classless interdomain routing, and the earlier section. An easier way to apply subnetting. Table 8.5 summarizes how you break down a Class C network into 1, 2, 4, and 8 smaller subnets, and it gives you the subnet masks, network numbers, broadcast addresses, and router addresses. The first 3 bytes have simply been designated X, Y, and Z. Note that the table assumes you can use all the zeros and all the ones subnets too. So we'll just go through this quickly. Number of desired subnets, subnet mask, network number, router address, broadcast address, remaining number of IP addresses. So 1.255.255.255.0, x.y.z, 0, x.y.z.1, x.y.z.255.253. 2.255.255.255.128, x.y.z.0, x.y.z.1, x.y.z.127, 125, 255.255.255.128, x.y.z.128, x.y.z.129, x.y.z.255.125. 255.255.255.192, x.y.z.0, x.y.z.1, x.y.z.6361. 255.255.255.192, x.y.z.64, x.y.z.65, x.y.z.127, 61. 255.255.255.192, x.y.z.128, x.y.z.129, x.y.z.191, 61. 255.255.255.192, x.y.z. 192, x.y.z, 193, x.y.z, 255, 61, 8, 255.255.255.224, x.y.z.0, x.y.z.1, x.y.z3129. 255.255.255.224, x.y.z32, x.y.z33, x.y.z6329. 255.255.255.224, x.y.z64, x.y.z65, x.y.z9529. 255.255.255.224, x.y.z.96, x.y.z97, x.y.z12729. 255.255.255.224, x.y.z128, x.y.z129, x.y.z15929. For example, suppose you want to chop up a Class C network 200.211.192.x into two subnets. As you can see in the table, you'd use a subnet mask of 255.255.255.128 for each subnet. The first subnet will have a network number of 200.211.192.0, router address 200.211.192.1, and a broadcast address of 200.211.192.127. You could assign IP address 200.211.192.2 through 200.211.192.126. That's 125 additional IP addresses. The second subnet would have the network number 200.211.192.128, router address 200.211.192.129, and a broadcast address of 200.211.192.255. Determining the subnet numbers for a Class C subnet. The first subnet always has a 0 in the intersecting octet. In the example, it would be 200.211.192.0, the same as the original non-subnetted network address. To determine the subnet numbers for the additional subnets, first you have to determine the incremental value. I begin with the octet that has an interesting value other than 0 or 255 in the subnet mask. Then subtract the interesting value from 256. The result is the incremental value. If, again, you use the network 200.211.192.x and a mask of 255.255.255.192, the example yields the following equation: 256 minus 192 equals 64. Thus, 64 is your incremental value in the interesting octet. The fourth octet in the case. Why the fourth octet? That's the octet with the interesting value 192 in the mark. Okay, so that's 1, 2. To determine the second subnet number, add the incremental value to the 0 in the fourth octet of the first subnet. In the example, it would be 200.211.192.64.3. To determine the third subnet number, add the incremental value to the interesting octet of the second subnet number. In the example, it would be 200.211.192.128. 4. Keep adding the incremental value in the fashion until you reach the actual subnet mask number. For example, 0 plus 64 equals 64. So your second subnet is 64, and 64 plus 64 is 128. So your third subnet is 128. And 128 plus 64 is 192. So your fourth number is 192. Because 192 is the subnet mask, this is your last subnet. If you tried to add 64 again, you'd come up with 256, an unusable octet value, which is always where you end up when you've gone too far. This means your valid subnets are 0, 64, 128, and 192. The numbers between the subnets are your valid host and broadcast address. For example, the following are valid hosts for two of the subnets in a Class C network with a subnet mask of 192. The valid hosts for subnet 64 are in the range 65 minus 126, which gives you 62 hosts per subnet. You can't use the 127 as a host because that would mean your host bits would be all ones. The all ones format is reserved as the broadcast address for that subnet. The valid hosts for subnet 128 are in the range 129 minus 190 with a broadcast address of 191. As you can see, the solution wastes a few addresses, 6 more than not subnetting at all, to be exact. In the Class C network, this would not be hard to justify. The 255.255.255.128 subnet mask is an even better solution if you need only 2 subnets and expect to need close to 126 host addresses per subnet. Calculating values for an 8-subnet Class C network. What happens if you need 8 subnets in your Class C network? By using the calculation of 2x, where x is the number of subnet bits, you would need 3 subnet bits to get 8 subnets. 23 equals 8. What are the valid subnets and what are the valid hosts of each subnet? Let's figure it out. 1.1.1.0, sorry, 111.0.0.0.0 is 224 in binary, and it would be the interesting value in the 4th octet of the subnet mask. This must be the same on all workstations. To figure out the valid subnets, subtract the interesting value octet from 256. 256 minus 224 equals 32. So 32 is your incremental value for the 4th octet. Of course, the 0 subnet is your first subnet as always. The other subnets will be 32, 64, 96, 128, 160, 192, and 224. The valid hosts are the numbers between the subnet numbers, except the numbers that equal all ones in the host bits. These numbers will be 31, 63, 95, 127, 159, 191, 223, and 255. Remember that using all ones in the host bits is reserved for the broadcast address of each subnet. The valid the valid subnet host and broadcast address are as follows: subnet host broadcast 0, 1, 30, 31, 32, 33, 62, 63, 64, 65 minus 9, 94, 95, 96, 97, 126, 127, 128, 129, 158, 159, 160, 161, 190, 191, 192, 193, 222, 223, 224, 225, 254, 255. You can add one more bit to the subnet mask just for fun. You were using 3 bits, which gave you 224. By adding the next bit, the mask now becomes 24011110000. By using 4 bits for the subnet mask, you get 14 subnets because 24 equals 16. This subnet mask also gives you only 4 bits for the host address, or 24 minus 2 equals 24, and 2 equals 14 hosts per subnet. As you can see, the number of hosts per subnet gets reduced rather quickly for each host bit that gets reallocated for subnet use. The first valid subnet for subnet 240 is 0, as always, because 256.240 equals 16. Your remaining subnets are then 16, 32, 48, 64, 80, 96, 112, 128, 144, 160, 176, 192, 208, 224, and 240. Remember that the actual interesting octet value also represents the last valid subnet. So 240 is the last valid subnet number. The valid hosts are the numbers between the subnets, except for the numbers that are all ones, the broadcast address for the subnet. Table 8.6 shows the numbers in the interesting fourth octet for a Class C network with 8 subnets. So table 8.6, subnet hosts a broadcast 0, 1, 14, 15, 16, 17, 30, 31, 32, 33, 46, 47. 48, 49, 62, 63, 64, 65, 78, 79, 80, 81, 94, 95, 96, 97, 110, 111, 112, 113, 126, 127, 128, 129, 142, 143, 144, 145, 158, 159. 160, 161, 174, 175, 176, 177, 190, 191, 192, 193, 206, 207, 208, 209, 222, 223, 224, 225, 238, 239, 240, 241, 254, 255. Subnetting Class B. Because a Class B network has 16 bits for host addresses, you have plenty of available bits to play with when figuring out a subnet mask. Remember that you have to start with the leftmost bit and work toward the right. For example, a Class B network would look like x.y.0.0 with a default mask of 255.255.0.0. Using the default mask would give you one network with 65,534 hosts. The default mask in binary is 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0. The ones represent the corresponding network bits in the IP address, and the zeros represent the host bits. When you're creating a subnet mask, the leftmost bits will be borrowed from the host bits. Zeros will be turned into ones to become the subnet mask. You then use the remaining bits that are all set to 0 for the host address. If you use only one bit to create a subnet mask, you will have a mask of 255.255.128.0. If you use 2 bits, you have a mask of 255.255.192.0 or 1, 1, 1, 1, 1, 1, 1, 1 dot 1, 1, 1, 1, 1, 1, 1, 1, 1 dot 1, 1, 0, 0, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0, 0, 0. As with subnetting a Class C address, You now have three parts of the IP address: the network address, the subnet mask, the subnet address, and the host address. You figure out the subnet mask numbers the same way as you did with a Class C network, but you'll end up with a lot more hosts per subnet. There are 4 subnets because 2 equals 4. The valid third octet value for the subnets are 0, 64, 128, and 192. 256 192 minus 192 equals 64. So the incremental value of the third octet is 64. However, there are 14 bits zeros left over for host addressing. This gives you 16,382 hosts per subnet. 214 minus 2 equals 16,382. The valid subnets and hosts are as follows. Subnet hosts broadcast x.y.0.0, x.y.0.1 through x.y63.254, x.y 63.255, x.y.64.0, x.y 64.1 through x.y 127.254, x.y 127.255, x.y 128.0, x.y 128.1 through x.y.191.254, x.y 191.255, x.y 192.0, x.y 192.1 through x.y.255.254, x.y 255.255. You can add another bit to the subnet mask, making it 1, 1, 1, 1, 1, 1, 1, 1 dot 1, 1, 1, 1, 1, 1, 1, 1 dot 1, 1, 1, 0, 0, 0, 0, 0 dot 0, 0, 0, 0, 0, 0, 0, 0, or 255.255.224.0. This gives you 8 subnets, 23, 8 and 8, 190 hosts. The valid subnets are 0, 32, 64, 96, 128, 160, 129, and 224, 256, 224 equals 32. The subnet's valid hosts and broadcasts are listed here. Subnet hosts broadcast x.y 0.0, x.y 0.1 through x.y 31.254, x.y 31.255, x.y.32.0, x.y 32 through x.y 63.254, x.y 63.255, x.y 64.0, x.y 64.1 through x.y 95.254, x.y 95.255, x.y.96.0, x.y.96.1 through x.y 127.254, x.y 127.255, x.y 128.0, x.y 128.1 through x.y 159.254, x.y 159.255, x.y 160.0, x.y 160.1 through x.y 191.254, x.y 191.255, x.y 192.0, x.y 192.1 through x.y 223.254, x.y 223.255, x.y 224.0, x.y 224.1 through x.y 255.254, x.y 255.255. The following are the breakdowns for a 9-bit mask with a 14-bit mask. If you use 9 bits for the mask, it gives you 512 subnets to 9 with only 7 bits for hosts. You still have 126 hosts per subnet. 2, 7, 2 equals 126. The mask looks like this: 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 0, 0, 0, 0, 0, 0, 0, or 255.255.255.128. If you use 14 bits for the subnet mask, you get 16,384 subnets 214, but only 2 hosts per subnet. 2, 2, 2 equals 2. The subnet mask would look like this: 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 0, 0, or 255.255.255.252. Subnetting Class A. Class A networks have even more bits available than Class B and Class C networks. A default Class A network subnet mask is only 8 bits or 255.0.0.0, giving you a whopping 24 bits for a host to play with. Knowing which hosts and subnets are valid is a lot more complicated than it would be for either Class B or Class C networks. If you use a mask of 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, dot 0, 0, 0, 0, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0, or 255.255.0.0, you'll have 8 bits for subnets, or 2256 subnets to 8. This leaves 16 bits for a host, or 65.534 hosts per subnet. 216 minus 2 equals 65,534. If you split the 24 bits evenly between subnets and hosts, you would give each one 12 bits. The mask would look like this: 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 1, 1, 1, 1, dot 1, 1, 1, 1, 0, 0, 0, 0, dot 0, 0, 0, 0, 0, 0, 0, 0, or 255.255.240.0. How many valid subnets and hosts would you have? The answer is 40,096 subnets, each with 4094 hosts. 212 minus equals 4094. The second octet will be somewhere between 0 and 255. However, you will need to figure out the third octet, because the third octet has a 240 mask. You get 16. 256 minus 240 equals 16 as your incremental value in the third octet. The third octet must start with 0 for the first subnet. The second subnet will have 16 in the third octet, and so on. This means that some of your valid subnets are as follows, not in order: subnet hosts broadcast x 0255.0.0, x dot 0255.0.1 through x.0255.15.254, x0 minus 25 dot, sorry, 0 minus 255.15.255, x 0 minus 255.16.0, x 0 minus 255.16.1 through 0, x minus 255.31.254, x 0 minus 255.31.255, x 0 minus 255.32.0, x 0 minus 255.32.1 through x 0 minus 255.47.254, x dot 0 minus 255.47.255, x 0 minus 255.48.0, x dot 0 minus 255.48.1 through 0, through x 0 minus 255.63.254, x dot 0 minus 255.63.255. They go on this way for the remaining third octet values through 2 to 4 in the subnet column. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.